I'm actually really nervous because there are a lot of people here.
There's a lot of people.
Yeah, like all these people.
Nice.
Yes.
Alright. Some things we wish we could have done differently. We're sticking to the plan kind of when we are going to finish and all the times you're going to meet. Another thing was being careful who we choose to do what job. You want the manager to obviously manage and show up. Another thing is we wish we could have started earlier. The craft center, we weren't really aware that it was on campus till about a month after. If we had done some more exploration, we could have found out that the craft center was there and worked earlier. Another thing we wish we could have done was test more, like the projectile and everything, and also research the projectile more and the past projects to see what would work. And in doing that, we probably would have figured out that the spring wouldn't work and air pressure would be best.
The team had to use the engineering design cycle during the process of building our precision launcher in order to make the best launcher possible. So our step one was to define the problem, which was to make a precision launcher that met all the requirements given by our D101 instructor. And step two is what is needed in the restrictions on our project. And one of the restrictions was that the projectile had to be between 1/2 inch and 5-inch diameter, so that was pretty restrictive, and we actually chose to use that bar right there. Number two was the ability to be enclosed in a 4x4 cube, and that included the launching mechanism. The third restriction was only human intervention could be used to set it and release the weight, so you can touch it and do anything during the process of it. The fourth step, or fourth thing, was the launcher must include 2 methods of energy transfer, which was also hard to do, so it couldn't be like a simple release. And then another restriction was the launcher must be reset and reloaded in 30 seconds between launches. That was also tough to do. Moving on to step 3 was to brainstorm solutions. So we had to have a base made by 2x4 pieces of wood, pulleys for the rope to move around, an eye hook for the launching mechanism, bungee cords and springs, and the Nerf ball gun for the projectile. So we used that. Then step 4 and 5 was to create, test, and evaluate the results. So we designed a precision launcher that met all the requirements, and we tested it, and we realized that it didn't launch the recommended amount, and it sometimes didn't even launch at all. So we had to go back through the entire design cycle and make sure that all the restrictions were met, all the needs were met, and we had to brainstorm more solutions until we finally arrived at our final design.
So some of the challenges we faced with the precision launcher was being able to get the entire machine inside the square that we had to, because the original idea that we had, since we only had 5 pounds to work with, was that we have some sort of arm that launches, but that always kept going outside the box. So we ended up fixing that by using springs to make a crossbow-like design, and even with the springs, 5 pounds wasn't enough, so we had to stretch those out to lower the spring constant so we could launch with less weight.
Would have followed you. Say something, I'm giving up on you. And I am feeling so small. It was over my head. I know nothing at all. And I will stumble and fall. I'm still learning to love, just starting to crawl. Say something, I'm giving up on you.
If we could give advice to next year's freshmen, it would be to start working early in the year, get as many materials as possible donated to you, spend an adequate amount of time planning, and don't get your hopes up that the project will actually work.
Anywhere I